Welcome to Tectonic Nights channel. In this week's Gen AI project series, we'll dive into analyzing the sentiment of YouTube comments using OpenAI and LangChain. In this video, we'll focus on the comment from MKBHD's review of Sora. A quick introduction to Sora. It's OpenAI's new video generation model that can take text, images, and videos as input and generate entirely new videos as output. We'll analyze the overall sentiment, highlighting both positive and negative feedback, and also look at any suggestions or insights shared in the comments about Sora. A high-level overview includes 3 steps. First, we'll fetch the comments from YouTube video using YouTube Data API. Next, we'll classify and tag the comments using OpenAI's API, categorizing them as positive, negative, suggestions, and questions. Finally, we'll summarize each category of comments using LangChain. Let's get started. We'll be using comment threads list API to fetch all conversations for a video. Let's walk through the key request parameters. First one is the part parameter. We'll specify part equal to snippet, which gives us a quick overview of comment thread. This includes top level comments without fetching all of the replies. Next is the max result. We'll set it to 100, which is the maximum allowed. For pagination, we'll use the page token parameter to continue fetching additional comments if there are more than 100 results. Here's the response structure. The response will include a next page token and a list of common thread resource items. Let's break down the structure. Each common thread resource structure is as follows. The top level comment is located within the snippet resource. This contains the primary comment, referred to as the comment resource. Each comment resource includes several details, but we are mainly interested in the raw comment text, which is located in the text display element. Let's take a look at the code snippet. Here's the request object and here's the corresponding response. Next, we'll proceed to classify the comments. First, we'll configure the OpenAI API key and define an output structure for the language model. We will use Pydantic, a data validation library, to create a classification class with the following lists: positive, negative, and suggestions. Each of these categories will be defined as lists in the structure to instruct the language model to extract the sentiment of the comments and categorize it accordingly. A quick introduction to Pydantic. Let's consider an example of data model defined using Python's data class decorator. In this model, we have positive comments field of type string and a positive count field of type integer. If we create a classification object with data types that don't match the defined types, no validation occurs. For example, if we assign a string to positive count, which should be an integer, the object will be created without any validation. However, when we later retrieve the variable and attempt an integer operation on it, an error is thrown. In contrast, Pydantic automatically performs data validation, eliminating the need for manual checks. It ensures that data conforms to the expected types and raises appropriate validation errors when there's a mismatch. Pydantic also offers a variety of built-in methods for serialization. For example, the model dump method returns the model data as a dictionary, while the model dump JSON method returns the data in JSON format. Additionally, Pydantic integrates seamlessly with LLMs, making it easy to structure and generate responses according to the defined schema. We will define our prompt template where we explicitly instruct the LLM to extract only the properties mentioned in the classification class. We'll use the GPT-4o mini model with a temperature setting of 0 to ensure deterministic or predictable outputs. Additionally, we'll specify the output structure with structure output method, which will use define classification class. Now let's test it out by evaluating a few sample comments. We'll invoke the LLM to classify the sentiment of these comments. We use model dump method here to return the response as a dictionary of classifications. To avoid context length errors with LLM, we can process the comments in batches rather than sending the entire comment list at once. We'll define a chunk size here, let's say 500, and slice the comment list into smaller batches based on its size. Each batch is then processed individually by the LLM. The results from each batch are stored in a variable, LLM results, and append it to the final result list. Finally, we can summarize each of these lists using LangChain's createStuffDocuments chain method. This allows us to create separate documents for the categories of positive, negative, and suggestion-based comments. We specify a prompt that instructs the LLM to provide a summary and use GPT-4o mini model again for this task. We then generate a chain using createStuffDocuments chain method for summarization. There are two common approaches for summarizing using LangChain. One involves creating a stuff document chain with createStuffDocuments chain function, while the other uses MapReduce documents chain. The MapReduce approach is used when summarizing larger documents that don't fit within the LLM's context window. In our case, since the document size is not large, we'll be using the first approach. Here's the summary of the positive documents. Next is a summary of negative documents. Lastly, here are the consolidated suggestions. Thanks for watching. If you found this video interesting and want to explore more projects on GenAI, check out my other videos in GenAI project series playlist. Don't forget to subscribe so you don't miss out on future updates and exciting content.